So it's lesson 12. Thanks for joining today. I had to postpone things because I was in another meeting. And I've got another meeting starting at 3. So we will do a short and sweet web API lesson today. I also want to talk about our final exam. So our exam is on Saturday I believe it's from 1 to 4 p.m. I'll just double check that in my calendar, but I believe it's 1 to 4 on Saturday. Our final exam will be similar in format. Sorry, I'm just double checking Saturday. Or if somebody wants to confirm the time, I'll double check. So it's 3 hours. The format's going to be very similar to our midterm exam. It's going to be all practical. And there will be multiple versions of the exam, just like there was in the midterm. So you are not guaranteed to get the same version of the exam as everybody else does. There will be some low stakes marks for some basic things from the first half of the course, but the focus of the exam will be things we've covered in the second half of the course. So that will include things like security, unit testing, the web API that we're going to do today. Sorry, we didn't do a midterm. I'm sorry, Jacob. You guys didn't have one. I had them in my other sections. Thank you. It's been a crazy day. Thank you for correcting me. No. I had planned to do a midterm, but because we lost 2 weeks, one with Family Day and one because the semester didn't start and because of Labor Day, I didn't want to take up another class with a midterm. We're already just trying to squeeze in web API. So it will be a practical exam, okay? I may provide a database. You will not need to use Azure, so don't worry about that, okay? So you can either run a local database or I might provide a shared database for you to use. So there'll be several different versions and it will be all practical. There's no question and answer. Okay, and I'll have you be sure to sign into the WebEx room. If you have questions during the exam, you can use the chat to send me a message. I'll also be asking you to make a commit to GitHub every 30 minutes so I can see your process through the exam and see the evolution of your submission. Does anybody have any questions about the final exam? It's possible, Mason, but one thing you will not use, we were not going to be using Stripe. So I'm not assessing you on Stripe. That was just like a nice to learn bonus feature of the course. It is not going to be assessed. But yes, something like social authentication, I mean, that's part of the course content. Well, Stripe was the payment gateway. Yes, the payment gateway we integrated in the cart, that will not be on the exam. Okay, anybody else? Any questions? See if we can find, I will just confirm the time. If I can find it here. Or if someone has the link or can confirm the time, like I said, I believe it's at 1 o'clock. But if somebody would like to confirm that it's 1 o'clock on Saturday. But I will send out an email. Thank you, Megan. It's directly on the Lakehead site. Okay, so yes, 1 to 4 o'clock. So you just come into the regular WebEx room and we will hold the exam in here. in terms of the best way to practice, what I would suggest is take your last chapter bookstore or your assignment once I'm finished marking it. And if there's anything that is not fully working there, then try to clean it up, try to fix any issues that you can see there. Or you can even take your assignment and add some additional functionality once I am done marking it. Or you can make changes locally to it, I guess, without uploading those. Okay, so let's open up our last chapter store. So I'll open up, it's our kind of last lesson together. Actually a little bit sad, we've had 2 classes together. I don't think we have one together in January, but you guys have been a fun group. I've enjoyed teaching you. So let's open up our project. Jacob, I have taught it in the past. I'm actually the one that developed the current curriculum for the course, but I have a section of that course in January, but it's for the web program. So I'm not sure. Now I know in the past we've had different people teaching JavaScript frameworks. We've had Chris Naismith, we've had Sean McKinnon, who are both graduates, and they're both excellent. So you may have one of those instructors. If you do, you're very lucky. They're extremely knowledgeable. But I don't know, it could be someone else doing that course. It won't be me. Like I said, I'll have a section, but it's in the web program. So I'm not teaching that. Well, thanks, Mason. I appreciate that. Okay, so let's open up our project. So what we want to do today is we actually want to use some of the tools in Visual Studio to build our own REST API. You've probably heard this term before. I'll put it in the chat. A REST or RESTful API. Does anybody know what does REST actually mean? What does it stand for? Anybody heard this term before? REST? Maybe you've heard it, but you don't know what it is. So we're going to talk a bit about REST, look at some of the basic terminology, and then we're going to generate it. Thanks, Mason. Okay, REST API. I'm going to put this into the chat so everybody can see. Right, it's an API that conforms to the constraints of a REST architectural style and interaction with RESTful web services. And what it stands for is representational state transfer. So REST, much like MVC, is an architecture pattern for putting together an application. REST is a style of building APIs, and it's kind of become the standard for modern API development. So, and part of the idea is we have this kind of standard, this uniform interface. So most REST APIs, they look the same, okay? And things are stateless, so every request is unique. It's not tied to any previous data or previous requests. And typically, most modern APIs, most REST APIs, originally they used to transmit data in XML format. We'll still see some old APIs out there, but JSON is the kind of the common language that we interact with. And HTTP, what we use are common methods in APIs. So the common methods we tend to have in REST APIs are GET for reading data, POST for creating new resources, deleting, which is self-explanatory, and then we have a method called PUT, which is typically used for updating resources. So we can have a look. So here's we can have a look at a common API. So for example, we want to go and look at something like Spotify. So if we wanted to integrate with Spotify in a web application, right? We've got an application, maybe we build it in .NET or Node.js or PHP or something else, but we want to integrate with Spotify's API service. So it gives us a default URL. So the basic address is api.spotify.com, and it has a set of endpoints. So each endpoint is a different URL, and then we can see the kinds of requests. And here are our REST methods. So get is for reading, post is for creating, put is for changing, and delete is deleting. So they give us examples here. We're familiar with some of these HTTP status codes. We've been working with them. So this documentation describes how we would consume or interact with Spotify's API. Now we've already integrated a few APIs into our project, right? We've integrated the Stripe Payment Gateway API by making C# calls. We've integrated Google Login, which lets us sign in through Google. And again, we get JSON responses from Google. But what we want to do is we actually want to develop our own API within the last chapter. So not only do we want to develop it, but we're going to use a tool that will actually generate documentation for the API. Because it's one thing to build your API, but in order for anybody to use it, we also have to document it. So for example, in Spotify, if we want to get a list of albums, or here's how we get an album. So there's documentation here where it gives us the URL, it tells us the parameters, it shows us the kind of responses, and gives us JSON samples. So there's a cool tool that we can use that once we build an API, it will automatically generate the documentation for us. Oh, curl. So curl is a command request where we can make HTTP requests from the command line. So if you copied that command and ran it in your terminal, it would actually make the API call there. So we're going to quickly build and document a tool in Visual Studio, and we can do this before 3 o'clock. So I'm going to go to my Solution Explorer. Inside of controllers, I'm going to right-click my controllers folder, and I'm going to add a new folder. So I'm going to create a folder inside of controllers. And I'm going to call it API. So I've now got this empty subfolder here called API. And I'm going to use the Visual Studio tools to scaffold a new API controller. So I'm going to right-click my API folder. I'm going to add a controller. Now notice on the left, it defaults to an MVC controller. So we've used MVC empty controllers, we've used MVC controller with views using Entity Framework. But this time we don't want an MVC controller. I'm going to pick API instead. So under Common, I'm going to choose API. And then we get kind of similar choices. We can get an empty API controller, an API controller with read and write actions, or an API controller with actions using Entity Framework. So what does this do? This will give us a controller with REST actions to perform create, read, update, delete, and list using an Entity Framework data context. So we're going to pick this one. Again, click API up here. Click API controller with actions using Entity Framework and click Add. Much like with our web controllers, we have to specify if we're going to use Entity Framework, wants to know which model do we want. So we're going to make an API controller based on our book model. The data context is automatically going to default to our one and only database connection object, our application DB context that we've been using throughout the semester. And if we pick the book model, again, it'll give us the name of books controller as a plural. So that's fine. I'm going to leave that name, and I'll click Add. So the scaffold tool is going to run, and it's going to do similar things to the books controller we scaffolded a while ago. So some similar things and some differences. So here's our controller. So we've got methods, all our CRUD methods here. Maybe I'll just close up all my files except my new API controller and the original MVC controller for books. So if you have a look at these two, what are some differences that you notice between these two? There's a bunch of things that are similar, like they've got a constructor with a database dependency. But what things do you notice that are different? Okay, thanks, Chris. Right, so we've got some annotations here, right? That says this is an API controller, and it also specifies that the root, so the URL to call our controller, is going to start with the prefix of API. Okay? We also see Chris mentioned annotations on the class level, but he also said we see annotations at the method level. So we've got HTTP GET here, and then we've got put for our update method, post, which we've seen before. We do see this in our regular API controller, right? Our create and edit, there's our post. And then we've got an HTTP delete as well, okay? So those annotations are different. Thanks, Chris. Anybody else? What else do you see that's different between our API controller and our MVC controller? A couple other things are different if you look inside the methods. So take a look, for example, at the get with an ID parameter. Aha, okay, some return no content, right? So for example, when we're putting, after we do an update, right, it just returns a no content, which is a 204 response. So that's an okay, but with no content. Whereas, yeah, in the web project here, after we do a successful post of an edit, right, it returns a redirect after saving, takes us back to the index view. Well, there are no views. In fact, if we look at the return statements in our API controller, these only return HTTP status codes. Now, they might return a data model, like here after we create a book, after we do a post, we'll send back that new object, but it also just sends a 201 response. So we're not calling, there's no front end here, right? This is just a service that allows another application to perform CRUD operations. Can anybody think of what would be the use for this? Like how might this API controller get used? If there's no front end to it here, can you think of any business case where this controller might be useful? I could think of a few. What would the value be in us creating this API? Okay, Ivan, that could be. Let's think about the purpose. Aha, okay, that's a good suggestion, Chris. If another website requests a book from our store, okay, exactly. So let's say someone else, a partner wants to sell our books in their store, right? Maybe they're gonna give us for a commission. That would be one example. So now, right, if we go here, so if I go to /API/books, I get nothing. I'll need to build my project, which I neglected to do. But if we build our project, and then we go to /API/books, I now get a JSON representation of all the books in the books table. So another website could now access, they don't have direct access to our database, right? We're not providing them with a username and password to go and query our database. We're building a service to expose this data to another application. So this application could be another website, like a partner, for example. Right? This is really what Spotify's API is doing. It's allowing us to get, albums or tracks to use this data in another application. Could you think of any other business case for this? Any other reason why having this API available, who else might want to use it besides another website? What other kind of application might have use for our API? So Chris gave a great example. Anybody else think of another business case? Give you a clue. How would this API be useful with this device? Thank you. That's right, Megan. Right? We want to make a mobile app so that I can actually browse, not in a browser, but I want a native app on my phone or my tablet that has access to browse what's in the store. I'll actually show you a real world example of this. Let's go here. So this was actually a student project. I'll show you the app in the Google Play Store. So this app was developed by students here at the college. So here's the front end of the app. It was using the Ionic framework, but it's in both the Google Play Store and the Apple App Store. So the front end is Ionic, but the back end, I can even show you, there's actually two different GitHub repositories. Bear with me, maybe I can find it. Oh, I think I transferred. Hang on, maybe I can find it. Aha, okay, so here we go. So here's the client. This is the app with the client. It's all front-end JavaScript, Angular and Ionic. But the back end that serves the data to the database, it's, guess what? An ASP.NET MVC API. So we've got different controllers. So things like the employer's controller. It's a job matching application. So we've scaffolded and then customized the API because all of the data for the mobile app gets sent, all the CRUD operations happen in this .NET API. So we can make changes to it. So there's no views returned, everything is JSON. So here's our list of books on line 28, right? This queries our database context, fetches our list of books, converts it to a list, which populates a JSON object here. Now we can make the same kind of change in our API that we did in the web project, right? So right now it's fetching the books based on the primary key value. So 1, 2. So this is in order by primary key. Maybe we want to modify this. So instead, before we convert it to a list, maybe we want to order by with our Lambda expression, right? We want to order by the, let's say, the book title instead. So we can take the scaffolded code that runs this query. We can customize it to suit our purposes and save our change. So now if we make a GET request to our REST API again, this time, rather than having our books being ordered by ID, the books should be ordered alphabetically by title. So if I reload, now book ID 2 is at the top because it starts with A for Animal Farm. And my book ID 1 is actually down at the bottom because alphabetically by title, it's now the last one in the list. So we quickly test out our API methods. So we see that the get works. So when we go to API/books, it fetches all the books. How would we, if we just want to get a single book, how could we do that? So we can actually see we've got 2 get methods here. And Visual Studio nicely gives us the endpoint, the URL endpoint for each one. So if we browse to API/books, it runs our getBooks method, which queries the database and gives us all the books in alphabetical order by title. What API, what endpoint or URL would we invoke if we want to select a single book instead? Again, we would make a get call. What would we do in our browser if we wanted to fetch one book record only? There's some clues around lines 31, 32, 33. Right, okay. We don't need an array because, Ivan, we actually have a method here. So this method gets all the records. But we have a second get method that will retrieve a single record from the database only. So rather than getting the full list and then identifying one element in the array, yes, we could do that. That would work. It's not a bad suggestion. This just might be a little more efficient. Let's just select that one book directly with the ID. So if up in my address bar, I can just add on a slash and enter in any valid book ID, right? And now it retrieves just that one object because our query takes that ID parameter and it calls find now what will happen if I put in an ID that isn't found? What kind of response should we get? from this get method. Okay, we will get a 404. We won't get a 404 page, however, right? Remember, our API, there is no front end to it. It only sends receive JSON and HTTP codes. So if I try this with an ID that doesn't exist, right, I get back an object. I get back a JSON object with the title of not found and a 404 status. And if I check my browser console, and go to network and refresh, right, my HTTP status code that gets returned is 404. Now we can test out the other methods in just a minute, and we will. But before we do, we're actually going to add a tool to our project that will automatically generate some documentation for our API. So a lot of the stuff we see here in Spotify that describes each API method, we can automatically generate these docs. Because if we're going to build an API for other applications to consume, we have to document it so the developers of those applications know what are the methods in our API, what are the URLs, and what kinds of parameters and responses do each of the API methods require. So we're going to go ahead and install a tool called Swagger. So I've put links to Swagger here, and there's a bit of a tutorial here about how to use it. So this describes using Swagger and OpenAPI. So OpenAPI is a specification for how to document APIs. So it's become kind of a standard. And Swagger is the tool that follows this OpenAPI so that it will generate our API docs for us. And they're going to kind of look like this. So we can use Swagger UI with another tool called Swashbuckle, and it will inspect our project for any API methods. It will document them, and it will also give us a little engine that we can actually test the API methods in our browser. So we can use that to actually add, edit, and delete a book through our API service. So there's a few steps we need to do in order to enable this. So you can read a bit more about, I know we don't have a lot of time, so I'm going to go fairly quickly, but the link is here if you want to read a bit more about the OpenAPI spec and Swagger. Yeah, I think it's pretty neat. And we're going to use Swashbuckle, which is the coolest name of all. So the first thing that we need to do is go to Tools, NuGet Package Manager. We want to manage the NuGet packages for the console so that we can install the library that we need. So we're going to use Swashbuckle for this. It's got the link here. So it wants us to install swashbuckle.aspnetcore.swagger. So I will just search here. So you can search for Swashbuckle. I'll put it in the chat. So do a search. Make sure you're on the Browse tab. And you want to search, and we want this package here. We want the second one that has 174 million downloads. We want swashbuckle.aspnetcore.swagger. So click on this. Which project do we need it in? The last chapter or the last chapter test project? Which project contains our API? So I want to check one of these. Which one do I need it? Yeah, not the test project. That's right. Thanks, Megan. Thanks, Chris. It's the web project because that's where the API lives. So check the last chapter project and we will click install. So it's going to install the Open API spec. It's going to install Swagger. I'll build my solution. So now we can make calls to the Swashbuckle library. So again, Swashbuckle, what it does, it exposes our JSON endpoints from APIs. So it's going to auto-generate a documentation file. So we just need a few lines of code. That's a really good question. What's the difference between the swashbuckle.ASP.NET Core.Swagger and just the Swashbuckle ASP.NET Core? As best I can tell, it's actually the version, I think. So this one, is .NET Standard version 2. This one is .NET Core version 3. So it looks like the one we installed just supports slightly later versions. But I'll have to look a little more carefully into that, Megan. It's only a partial answer. So now if we go to our startup file, we want to configure Swagger and Swashbuckle. So we've got one line inside our configure services method. So down at the bottom, what's called services.add Swagger gem. And I'm not sure why it's not giving me the prompt for a reference, but I think I'm gonna try manually adding a reference up at the top. See if this fixes it. So I can add a reference to swashbuckle.ASP.NET Core.Swagger. Does this fix my problem? We may need to install one other thing. Okay, you know what, Megan, I think you're a step ahead of me. I think I installed the wrong package. I think I did want this one instead. Oops. Okay, let's. Oh, it did. Okay, sorry. This is a dependency of this one. So when we install Swagger, we got this one. Because it shows. Oh, no, it doesn't. I'm sorry. I think I picked the wrong project. I think we need swashbuckle.ASP.NET Core. So the difference, Megan, between the one we installed and the one we didn't, I think, is that we needed this one. Because yes, this is the middleware that exposes it, but this is the tool for actually documenting the APIs. I'm sorry. So let's install swashbuckle.ASP.NET Core. Right, because we need these tools, the Swagger Gen and Swagger UI. Help if I read my own lesson notes. There we go. So now my add Swagger Gen method is enabled. Yes, I gave you the wrong instruction. I apologize. And we don't need this reference up here. Notice it's not being used. Just remove it. So that's the first step. Install the right package, and then we can add the Swagger generation tool. Then we need a few lines in the configure method. So this just kind of sets it up as a service. And then when app starts, use Swagger, generate API docs based on current version. So every time our application starts, it will regenerate the API documentation in case we've made changes. It does an inspection first. So we're going to first use Swagger, and then we will enable the Swagger UI to build HTML doc file for our API. So now we're going to use the Swagger UI, and we'll set out a couple of options here. So we're going to set out the Swagger endpoint, which will be Swagger. We're going to set out a JSON file, and we'll call it this is going to be, so we set out a URL as well as a title for our documentation file. Okay, so we're enabling the service, and then we're using the UI tools to build a documentation file. So we'll build the solution, and then we can take a look at what it generates. And what it generates will not only be a document file we can read, but it's actually interactive. So the documentation lets us actually test our API in our browser. We've been able to test the get method so far. Our browser just displays JSON, but we don't right now have an easy way to test the post, the put, or the delete. And Swagger is going to let us do that. So what does this look like? If I now just go to my root/Swagger, once I put my server back online, Swagger now takes the title we set out, and it says, okay, there's an API controller called books. Here are all the endpoints. It uses these models. So we can see, like if I want to send a book, it says, okay, well, the title can't be longer than 500 characters, for example. Sets these things out. I can also run these methods right here in the browser in the document. So if I expand my get, it says, okay, the get method, this get method, here's the URL. It takes no parameters. It will return either a 200 success response, and here's a sample. And if I click try it out, I can execute, I can make my API call right here. So it says, here's the URL, and here's the response. Right, here's all our JSON data, which we could then download, we could copy. Shows our response headers, our content type is JSON. If you wanted to run it from the command line, so Megan, you mentioned the command line, I could even copy this and try it in my command line if I wanted. Might even work something like my git bash prompt. it's a secure connection. I won't worry about that because of the HTTPS. So there's my get. I could try get a single book. So it says, hey, try it out. Click try it out. I'll put in some ID parameter and execute. And now it gives me back book 1004, again, as a JSON object. I can even try using this to add, edit, and delete a book. So I'm going to open up the post method. Gives me a sample of the schema. So I'm going to try to create a new book through the API. I'll click try it out. I'm going to take out the child data, like, so I don't need any child info. I'm going to take out the book ID. So my author will be, I don't know, some author. Title, a new book. My image, I'll just kind of leave it out. Price, 15. Mature content, false. Category ID is 1, because every book has to be in a category. So I'm just going to try, I'll dump this object in the chat. I'll see if I can actually submit this. I'm creating a new book. I'll click execute. Okay, bad request, so we got a 400 response. Let's see, what are we missing? Oh, I missed a comma after category ID. Put in a comma here, I'll try it again. Oh, I can't pass in a, let's see if I can do it just with category ID of 1. Okay, there we go. Here's my object. So I just assign it a foreign key. It gives me a 201 response. It says book ID is 2002. So now if I want to try that, I can go down to my get, put in ID 2002, and execute. Here's my new book. I could then try an update and a delete. Yes, normally, Megan, we would add authentication around it, yes. Or maybe we want our API to be read-only. So we have a few options. If we wanted our API to be read-only, we could just get rid of the put, the post, and the delete methods if we didn't need them. Otherwise, we would need authentication around our API, which we don't have time to get into, but you can read about it in the documentation. There's some description here. I'm trying to see if there's, yeah, for around security. So you can do that. Usually we use a method called JW2T, JSON Web Tokens. That's what Spotify does. So here in the header, you've got to provide some kind of authorization token in order to get access to their API. It's not open. You can't even make a GET request without the token. You have to be authenticated. And that's the way most REST APIs will work. So ours is open for now. So I'm going to go and take this object, I'll copy it, and then I'm going to try out the put and then the delete. So I'm going to copy my new book object. I'll scroll down to the put section. Say try it out. So my ID is 2002. And maybe I'll change the price. So I'm going to paste in my new book. I'm going to change the price. It's not selling. I'm going to mark it down from $15 to $10. So I can call the put method, which will do an update. So I'll execute it. I get a 204 response. Success. Now I can go back and run my get method again on book 2002. Just clear it out and execute. And now I can see that the price of my book has been updated from 15 to 10. So we can see that the put is working as well. And then if I want, I could go down to our delete method and try that. I'll scroll to the bottom, expand my delete, click try it out. I'll pass in ID 2002 and execute. I get a 204. And my book should be gone now. So if I go back up and now try a get request again, after I've deleted it, now retrieving it gives me a 404. Okay, so yes, we didn't have time to implement any security with it, but you can see with the scaffolding and Swagger how quickly you could generate an API in your Visual Studio project and document it using Swagger and Swashbuckle. Okay, so scaffolding, that's really how we built the back end. Students built the back end of this mobile app. They just created all their models, and then they scaffolded a controller, an API controller for each. And then they added security around it. So the API is secure, it's not public. Someone has to be signed into the mobile app in order to, and have an account in order to make calls to the API. Okay, so sorry we didn't have time to do a deep dive into this. There may still be some small API components on Saturday's exam. Okay, so again, our API, it's a JSON-based service that uses these REST methods, get, post, put, and delete for performing CRUD. There's no front end, but we would create an API so that another application has a way to, with its own UI, has a way to interact with the data in our own bookstore. And we can use Swagger to generate those documentation files. Does anybody have any questions? We've got a couple minutes. I'm going to stop our recording.